We are continuing group 17, the halogens. We're done with fluorines, so chlorine, bromine, and iodine, all with Ns2 and P5 electron configuration, 7 valence electrons, 1 electron deficiency towards noble gases. Repeating that chlorine is gas. At room temperature, when it's liquidified, it's yellowish liquid. Oxidation numbers from all these three are from -1 for chloride, bromide, iodide, 0 for elements, and up to +7. All of them are oxidizers. Chlorine production is made mostly by electrolysis. We already have seen down process with sodium manufacturing. Alternative is electrolysis of sodium chloride brine. The result is hydrogen gas, 35% sodium hydroxide, and chlorine gas. Chlorine compartment and sodium hydroxide hydrogen compartment are separated by membrane that is permeable for sodium ions. Chlorine makes a number of compounds with oxygen. Oxides are of +1 Cl2O, +3 Cl2O3, ClO2, which can dimerize to Cl2O4, Cl2O6, and oxidation number +7, Cl2O7. They can form corresponding acids, starting with hypochlorous acid, HClO, which is very weak, almost non-acidic. When chlorine dissolves in water, it makes HCl, hydrochloric acid, which is very strong, with chlorine -1, and hypochlorous acid, which is very weak, where chlorine is +1. When you mix two together and acidify solution, you have chlorine gas coming back. Next is ClO2 minus anion chlorous acid, which is still relatively weak. Two other acids, chloric and perchloric, are very strong. Chloride anion is bent. Chlorate anion is trigonal pyramid with lone pair above chlorine atom, similar somehow to sulfide. The difference is sulfide is an ion of very weak sulfurous acid, and chlorate is an ion of very strong acid. Perchlorate is tetrahedral. You can see that Cl oxygen distance drops down from oxidation number 3 to oxidation number 7 systematically. Perchlorates and chlorates can make potassium and sodium salts. All other salts are very unstable and explosives. Sodium and potassium salt of chlorate and perchlorate can also explode with some impurities, and they are based on numerous explosive compositions. Situation with different oxidation numbers of chlorine oxide is shown here. Starting with -1, which is chloride, that can react with concentrated H2SO4 to make HCl gas. Mixing with HClO or ClO-, it can make chlorine gas in its reversible process. Chlorine gas reacts with water to make Cl- and HClO. In alkaline solutions, this mixture will result in making chloride and chlorate ClO3-. ClO3- can be used to make ClO2 gas that can be used for sanitizing properties. Further oxidation of chlorate, usually by electrolysis, results in perchlorate, the highest oxidation number for chlorine. From perchlorates, you can make Cl2O7. Chlorine can react with fluorine to make ClF3 and ClF5. All two compounds have lone pairs, so to calculate their geometry, you need to take that into account. Here you see it's trigonal bipyramid with two lone pair domains here and there, so the resulting molecule is T-shape. Here you have tetragonal pyramid as the option, with lone pair looking down from base of pyramid. There is also ClF, similar to, say, Cl2 molecule. You can look at several nice videos of chlorine reactions with different elements and compounds. They are very entertaining.